This conference will now be recorded.
Hello students, we had been discussing previous year's questions from JEE Mains paper 2022 2nd September. So as you know, there will be two shifts in the morning and evening shift. So today we are going to start the evening shift question or second shift question. So we had before that we had 2 or 3 questions from the morning shift. Let me finish those things and then we'll continue with the second shift questions from the second shift. Okay, so this question says a 5 microfarad capacitor is charged by a 220 volt supply. It is then disconnected from the supply and is connected to another uncharged 2.5 microfarad capacitor. If the energy during this charge distribution is x by 100 joule, then the value of x is dash. So look, this question is very common question. Loss of energy when there is a distribution of charge. So initially there is a capacitor, say C1. So you have to actually answer this question to the nearest integer value. So initially there was capacitor which is charged with a supply voltage of 220 volt. That means after fully charged, this capacitor will have 220 volt across it. Now once you disconnect this capacitor, okay, 5 microfarad C1, and then connect it to some other uncharged capacitor C2, it has the total voltage. I'm saying this total voltage to be V1 and this V2 is 0 at this stage. Okay, when it is just connected, C1 has V1 voltage which is 220 volt. Okay, so 220 volt, but C2 is uncharged. That means it has 0 volt V2. Now once you connect these two, what will happen? The total charge what was there in this C1 capacitor will be distributed to C1 and C2 both, such that they can come to a common potential. Okay, they can come to a common potential, and let us say that common potential to be V. Okay, common potential is V. So if this is the situation, then the energy during this charge distribution, so energy, sorry, the change in the energy, if the change in the energy, this will be if the change in the energy, if change in energy during change, actually there will be loss of energy. So loss of energy during this charge distribution. So before you calculate the change in the energy, we have to know what was there in initially the energy was half C1, because okay, half C1 because it was charged, and V1 square. Okay, that means 5 into 220 volt square by 2. Okay, so this was the initial energy. Obviously this will be in joule or something. Now once you connect these two, after disconnecting the C1 from the battery, they will attain a common potential. If this is the common potential V, then I can write that the total charge C1 plus C2 into V will be exactly equal to C1 V1 plus C2 V2. Anyway, V2 is 0, so this part is 0, so I got C1 V1, which is equal to C1 plus C2 into V. So common potential V will be C1 V1 divided by C1 plus C2. Okay, now if we put the values, see 5 microfarad, so 5 into 10 to the power minus 6. Here also actually there will be a 10 to the power minus 6. 10 to the power minus 6. V1 is given as 220 volt divided by C. This is the C2, so C1 is 5, so this will be 7.5 into 10 to the power minus 6. 10 to the power minus 6. 7.5 into 10 to the power minus 6. This is the so this goes up, so it will be 5 divided by 5 into 2 to 0 0 divided by 75. This will be 15. So this will actually give you nearly 1.166.6. Okay, 166.6 you will get. 146.6. So this is what you get as common potential. Now we can find out the final energy, half C1 plus C2 into V square. Okay, so V is the common potential here. So I can write here into V square. V square is this 146 square. Now the loss of this energy, loss of energy will be, so loss of energy will be U I minus U A. So U if initial energy was half 5 into 5 into 10 to the minus 6 220 volt square minus half 7.5 146.6 whole square. So if you do this calculation, actually I have done this calculation. You can use the short trick to find out the answer for this. The best way will be you should not have this value. Okay, you should write in terms of 2200 whole square, etc. Those things you should have kept so that calculation will be a little bit easier. But anyway, since I have done it, so this will be kind of this much loss. So you have to answer this. See, it is said that this energy is actually x by so x by 100, right? The question was x by 100, and then what is the value of x? That means here, what is the value of x? So value of x, so the value of x will be 40. Okay, so this is the answer. Now this question says, this is actually from photoelectric effect, when a radiation of wavelength lambda is used to illuminate metallic surface, the stopping potential V when the same surface is illuminated with radiation of wavelength 3 lambda, the stopping potential is V by 4. If the threshold wavelength for metallic surface is L lambda, then what is the value of N? See, we know whenever this kind of problem comes, we will just directly go for Einstein's equation for photoelectric effect. We'll just directly write that. For photoelectric effect. So that is actually given by, see, the kinetic energy, maximum kinetic energy, that is equal to initial energy of the radiation minus work function. So these two things are equal. Okay, so what we can do, we'll write, since it is, see, energy is given in terms of lambda, so we'll write everything in lambda unit itself. If V the stopping potential, then potential energy will be EV. So that is equal to AC by lambda minus AC by lambda minus 5. So phi is the work function. Okay, this is work function. So this is for the first wavelength lambda, and when the wavelength is increased, then the stopping potential actually becomes 4, so B by 4. So AC by 3 lambda minus pi, this is work function, this is material property, this is same for everyone. Now see, from these two equations, what I can do, I can actually put this value EV here. So if I do that, then AC by lambda AC by lambda, so 1/4 minus pi minus pi. So this is equation 1, this is equation 2. Now see what I can do from here. See, I can actually find out pi from here. You have been asked to find out threshold wavelength. That means you need to know what is work function. Work function, and corresponding to that work function energy, you will get. So from here, if we solve this actually, what we should get? We should get phi is equal to, see, if we do this calculation carefully, we will get that. So let me just write it here in the other page. Equation 3 and first I can take, or equation 3 itself. Minus phi. AC by 3 lambda minus. So AC actually if we solve for, okay, solving for, so phi is equal to AC by 9 lambda. AC by 9 lambda we have got. Now see, if I consider, if threshold wavelength, then we can write, so AC by lambda 0 it will be, if lambda 0 is the threshold frequency, then AC by lambda 0 will be that phi 0. Now if I put this value, so this will be actually compared, so this phi will be AC by AC by HCl 9, in fact actually let me write it. So AC by 9 lambda 0. So if we compare this lambda, actually if we compare this lambda with this, then we will get actually lambda 0 is equal to 9 lambda. Okay, if we compare from both. So integer was n lambda. What is the answer then? Here 9 into lambda, 9 integer you have to write down. So this is the question, and next question, let us go ahead. This is also a very important question. A small point carrying some positive charge, sorry, point mass, carrying certain positive charges on it. It is released from the edge of a table. There is a uniform electric field in the region horizontal in the horizontal direction. Which of the following options then correctly describe the trajectory of the mass? Question is, suppose there was a table like this. So from the edge, one point mass, a point mass just dropped. Okay. Now here in this region there are electric field in this way. Okay. So there is a point mass having certain charge. It is located in the corner or edge of the table, and when it is released, see there is electric field inside in this direction also. So there is electric field along this way. So now the question is, see there are 4 graphs corresponding to the answers for this question. There are 4 options. You have to choose the correct option, which exactly implies that. So let us see here what is happening. Whenever this figure, whenever at this position, if you are at this position, so electric field is in this direction, right? And there will be another force acting on the object if it is freely falling object, that is G. So mg is mg is acting this way on the particle. Now what will be the trajectory? Okay, so now this question, now what is the trajectory of this particle? Let us see. See here in this direction there will be a force F into F is equal to Q into E, and this downward direction there will be weight of the body. Okay, object over A. So on the point side there are two forces acting. One is mg, another one is QE, electric force. Okay, so one is along I cap and this is along minus j cap. So you can understand that this particle will be undergoing its motion under the action of a force which is given by Q into E I cap minus M into G, M into G. Okay, so mgg, and this is this. So this is the force. That means so the particle will have both these components. So it will actually move like this in a straight line. Why straight line I am showing? Because see acceleration. Let us find out. So acceleration will be QE by M. So in this case, you look, the acceleration will be actually constant because the weight of the object is constant and electric field has uniform field and it is not a variable one. So both the electric and the gravitational force will act on the particle, so that's why it will be moving in a straight line, and few more supports are there for this question. So if it is straight line path, then this option 2 will be correct answer in this case. Okay, i I think it is okay. So see, whenever there is a constant electric field, sorry, constant acceleration of the body, then you must be thinking that either can have straight line or parabolic trajectory. But if the acceleration is constant, but again initial velocity is there, then it will be a parabolic. Okay, parabolic in nature. So I hope you have got this point. Let me just clarify it once again. See what happens. The force from the particle will be Q into E I cap and minus mg k cap. Okay. So what will be the acceleration? Then Q by m. Okay, so this is the acceleration which is a constant acceleration, and look, this is actually So if this is QE force and this is MG force. Okay, so this is from here itself we can understand, but again, this constant acceleration. Constant acceleration means the motion could be a straight line or a parabola. When there will be initial velocity, then it will be parabola, but in this case, uniform velocity, see, it started from rest. So rest means so actually with constant acceleration, constant A, you can have two types of trajectory. One is straight line, another one is parabola. Okay, so this is constant acceleration. So if initial velocity is 0, then it will be straight line. Okay, I'll give you simple example. Suppose an object which is just dropped, it will come in straight line with G. Okay, if you anti-parallelly apply the force, then also it will be a straight line. So this option 2 will be correct answer for this question. Okay. So this question says two uniform circular disks are rotating independently in the same direction, and their common axis, that means this. So there are two circular uniform indices, like dishes. Okay, so they are actually rotating in the same direction. Okay, so the moment of inertia and angular momentum of the disk 0.1 kg meter square and 10 radian per second. This is for the first one. So for the second case, this much, so 0.2 kg meter square per 5 rad per second respectively. So you have to actually find out at some instant they get stuck to each other, and starting as a single system about their common axis with angular speed. Okay, so the kinetic energy of the combined system will be. Okay, look, so there are two disks, suppose 1 and 2, both of see, both of them are rotating independently and their velocities might be given. So velocity of rotation. Now they have their individual I1, and this has moment plus I2 on the board, angular velocity omega 2. Now you have to so if we just add them with the Excel, then what will be the case? Actually, angular momentum remain constant. Okay, so this problem can be solved using angular momentum conserved L conservation. Okay, using angular momentum conservation. Okay, so initial it was I1 omega 1 plus I2 omega 2, right? This was initial one. Final one will be I1 plus I2 omega. So these are two equations actually. Now we have common moment of inertia I1 plus I2 into omega I have to calculate, where we had this known. Okay, so I1 omega 1 plus I2 omega 2. Okay, from here we can find out actually the omega, or maybe the whole part you can just calculate. Okay, and then you have to calculate the kinetic energy as well. Okay, rotational kinetic energy. So if we apply this, then omega could be found out like this: 0.1 sorry, this value is 0. Let me write the correct value: 0.2. Okay, so this will be actually radian per second. Now what is the kinetic energy? Half half I1 plus I2. Okay, so if we put the value properly, at least for the omega will just directly write here. You can just do this calculating. Okay, so I think this is 20 by 3, sorry. This should do 20 by 3 radian per second. So half the square and this I1 plus I2, which I have to add. So this is 0.1 plus 0.2. Okay, so if you calculate this, you will get 20 by 3 itself. So this is actually this much joule. Okay, so 20 by 3 joule. Okay, so I'll stop it here for today. Next class we will continue with the remaining questions. So thank you for your patience. Bye for today.